There comes a point in time when every IT organization must modernize for the sake of supporting its customers. Each of these journeys is entirely unique, and they all come with their own set of challenges. Not all of them are successful. Good afternoon, welcome to AWS reInvent. Today you're here to listen to Air Canada share their journey in modernizing an application that they call Enterprise Messaging Platform and utilizing a joint Red Hat and AWS service called Red Hat OpenShift Service on AWS, otherwise known as ROSA, to assist with this effort. My name is Dustin Scott. I am a senior black belt at Red Hat, which is a fancy way of saying that I help customers like Air Canada be successful with our managed OpenShift products like ROSA. I'm joined by Wender and Bharath, and they're going to take you on this journey today. We probably all know who Air Canada is and what industry they operate in, but what we probably don't understand is what happens behind the scenes. So Wender and Bharath are going to take us through and talk about how Air Canada IT builds platforms internally and ultimately how their culture of innovation helps lead to Air Canada's overall success as a business. They're going to talk about an application called Enterprise Messaging Platform, how they identified the need to modernize that application, its key requirements, some key architectural decisions, and how ultimately they landed on an application platform called ROSA. Now, some of you might not know what ROSA is, and that may be why you're here. But we're going to talk about what ROSA actually is and how it benefits customers like Air Canada. And I'm guessing you'll probably find something that you can benefit from as well. Finally, we're going to look at a practical example and take a look at how Air Canada actually provisioned EMP on top of ROSA, as well as take a look at where they're heading in the future. If we do this correctly, we'll have a couple minutes for Q&A at the end. Without further ado, I'll pass it off to these guys to introduce themselves and talk about Air Canada.
Thank you, Dustin. I wish we had cooler titles like you guys have, black belts. I guess it's going to be like a seatbelt manager at Air Canada if it's one of those. So let me introduce myself. So my name is Bharat Singh Reddy, and I am a manager for DevOps and SRE here at Air Canada. And also, I lead the practice for DevOps and SRE. So my day-to-day work or the things I deal with is to integrate or enable teams at Air Canada, the application teams, to embrace the DevOps processes and make sure we deliver properly with the highest quality, as well as with more secure and reliable operations. So today, Wender and myself will tag team on the journey that we had with Red Hat on the OpenShift, and also give you a glimpse on the challenges or the problems that we have faced and how we've solved with the EMP platform. And at the end of this session, maybe people who are not from the airline industry would appreciate how we solve the problems and the challenges at the airlines, and maybe at some point you're going to join the airline industry to solve bigger problems as well. Having said that, I'm going to shut up and give it to Wender to take over. Thank you.
Thank you. So my name is Wender. I am Cloud Specialist Lead. In our team, we are responsible to deploy infrastructure as a code, also applying the best practices. In the technology team at Air Canada, our main focus is think about customer experience. We have the digital experience, but behind the digital experience, we have also applications that support it, right? Today we're going to talk about one of the key systems or critical systems that is called Enterprise Message Platform. Before that, a little history about Air Canada. Air Canada is based in Montreal. It's founded in 1937. It's the largest airline in Canada. We have daily flights in 51 Canadian airports and also 51 US airports. There's an international network that extends to 6 continents and 36 million passengers carried on in 2022. In our industry, why innovation is key? Because it requires a significant financial investment and also relies heavily on human resources and also operates in a market with intense competition. As well, it involves complex processes such as operation, reservation, baggage, depart controls, and also subject to regulation and compliance. Again, and another one is very dynamic and sensitive factors influence this industry, such as weather. I'm going to pass to Bharat to continue.
Thanks. Thank you, Wender. So we touched on how dynamic our airline industry is, but we also want to, because weather is not only the one factor, right? So we have so many different factors, geopolitical things, and you need to be really nimble on handling these things. And we do have a lot of complex systems, right? So we need to have a culture around how we also need to handle these situations. And when we talk about the culture at Air Canada IT, we are aligned with the airline culture as well. So as an airline, we also always operate safely, securely, and reliable. And it's the same thing that goes with the IT as well. We want to build systems that are safe and secure, and we can trust on, and we can rely every single time. So reliability is a big factor as well. It's not only safety. Yes, for the airlines, safety is a big thing. Also is the reliability. So our customers always have a big expectations from us since it's a flag carrier. So we always should guarantee that we are on time or make it at least on time. So when we are talking about the customer experience, we always try to improve that, and we always want to improve the passenger experience. But how does it happen? It's not just you provide products or a hard product to the customers or better seats or comfortable seats. That's not the only thing. The pre-journey and the post-journey for the passenger is much more important as well. So we build tools for our frontline workers who actually interact with them on a day-to-day basis, and we always keep them in mind how they have to deal with them. Better tools, better information, it's much more smoother for our frontline workers to basically communicate with their passengers. That would give us a bit more trust because everything is going to be all right. If there is a certain weather issue, we need to communicate really well. So we always think about it. So we always make sure our ground handlers, our call center people, they have adequate information when they serve our passengers. When you consider all this, the two, it comes down to the operational efficiency, because we have to be as efficient as possible, as nimble as possible, and there's always a change, so that we cannot control. So we always look for this efficiency in our operations. So to do all these three, you need to always invest in technologies and are always on the lookout for any technology that can improve. And we have a special team or a unit that actually looks into these technologies. That either it can be AI, in the future it can be quantum computing, or maybe any other technology. They are always on the lookout just to make sure that we are competitive on the market and provide the best service that we can get. Now, talking about the culture, when we do these modernizations of the programs, at least when I joined Air Canada, I was in the middle of a biggest transformational program for ASC, and it was one of the best programs that we ever did. It's to transform our passenger core system, so which would basically, if we compare with something that so it's like changing the tire while a Formula 1 car is going on the circuit, and you're changing the tire. So passengers were flying, but we still switched the system to the new system without affecting the passengers. And it's one of the critical programs that that gave us more like a platform or a more motivation and confidence that we can do much better, bigger programs going forward. After that, we did the loyalty program, which is one of the best product right there. So it's so good that right now the passengers upgrading themselves more often or not because they're accumulating more points, more partners in the program, that sometimes when we travel as an employee, we don't get the upgrades. So it's so good. We always try to look for, is there's a passenger or an employee. So it's so good that it does happen, and we are at the bottom of the list. But it's a great thing to have because the guys who worked on it did an incredible job. It's a big transformation, and we delivered that during the height of the pandemic in 2020. So it's a testament that how we operate and how we work hard for delivering things. And there's no failure for us. There's no option for that. And the enterprise measures platform that we are building right now is part of the ops modernization program, which is the other biggest program to modernize our ops systems. And we're going to talk about one small part of the ops modernization platform, or the different messages that we have. So we talked about the culture, but what type of culture we are doing? I mean, we are moving to cloud. A lot of systems are on cloud. So what do? I mean, you can't just have different teams doing their own thing on these clouds. So we at Air Canada, we love building platforms, and that is something that we became expert in. So we always try to build platforms, and so that there's a bit more of practice around it. But I'll come to that next. So since we are in the airline industry, I want to just compare, just for fun, how the platform building, how we think, or the thought process of the platform building, and how we procure, let's say, big bulk airplanes for the AC, because it needs to be, you need to have a strategy, how it can serve for our future for the next 10 years or next 15 years. It's the same thing that when we do platform, when we build a platform, we always try to look to the future, and not really the immediate benefits, but in the long term, how it evolves. So let's compare. So when you build a platform on the cloud, so you want to try to reduce the cost in a way that how much you're paying for each computing unit. It's the same thing with when you procure an airplane. We want to compare how much it's going to cost for a seat mile. So if it's low, it's better for the company, better for the passengers as well, because your price goes down, and you can carry more passengers. Again, an airplane has redundant systems, 2 engines or 4 engines. You always have redundancy. So redundancy in systems, in sensors, and everything. Imagine. If you have only a single system, it's a catastrophe. I mean, generally, it's not recommended, but you always have that redundancy to make sure that it can land safely with even with one engine on the airport. So it's the same thing that when we build systems, these are critical systems, right? So we always make sure that we are on 2 regions, the primary and the DR region, so that something goes wrong in the primary, that we are always still operational without affecting the revenue or the operations of the airline. So again, the next part is, okay, when you build the platforms, that should serve smaller workloads or the bigger workloads. If you have a big applications that we want to move, it should support that. At the same time, it should also support the smaller applications as well. Now, when it comes to the airplanes, when you take this, especially, we tried to procure recently, we put an order for a 787-10, which are really, really efficient. And the 787s were kind of game changers for AC from 2014. So we wanted these airplanes to be adaptable. Like it should be profitable even if you run them on a shorter routes, as well as on international longer routes. So we always have that, and we still do it with the 787s. So now, our platform should support not only one specific type of application. It should not be just messaging or something. We want to look for platforms that can support different type of application technologies as well. It's the same thing, right? So our plane should support different types of seating configurations, different interiors. If you want to upgrade something, it should adapt to that. At the same time, you're not giving the performance for the plane. at the end. So when you build platforms on the cloud, you're expected to have low maintenance, which is good. It's not always that you have low maintenance, because when you go onto the cloud, you don't expect a full low maintenance, because you still have to maintain the infra. But when you take a platform as a service, you expect that it should be taken care by the teams that we take the platforms from. It's the same thing. So for the airline, if it's always on the ground, or if there's too much maintenance on it, then we don't make a lot of revenue. The more it flies, the more time it's in the air, the more revenue we generate. One last thing that I didn't mention here is the training, right? So you don't want, when you build a platform, you don't want to change everything for everyone, because the learning curve is a bit harder. Systems are there from last 20, 25 years. You don't want to change a lot of things. So you want to always put the new good things as well. So your developers don't need to learn and adapt to the new things, how they need to develop the applications. So which is something that we always look for. Same thing with when an airplane. So you don't want a lot of new pilot training or a lot of hours in pilot training. So that is always considered when you procure planes. So I think in that case, we are kind of, we have a synergy with when we procure and build platforms. And why we build platforms? So in the first place, why we want to really do it. So when we build platforms at AC, it might be our notifications platform, or digital, or integration platform, or in our case, enterprise messaging platform. We always, when we build these platforms, we build a practice around it. And a few people around this practice, they always try to improve the system. They always we start defining patterns and the standards around it, so that when we implement a change or when we implement a project, they are followed. When you follow certain standards and patterns, you have consistency. And when you have consistency, you're more efficient, because you know it's easy to implement, because you know you have already done it, and it's already implemented before. And there's a reusability. When you have reusability, your cost goes down, so you don't have to reinvent a lot of things again from the start. When you do all these three on the top, so you have more measurable performance, and your systems are more predictable. When you can measure your performance very accurately, you can see where the things are going wrong, or where the things you can improve. When you do that, you know what to do the change, how to improve. And when you do keep on adding new projects or integrating new things, there's a more bigger chance of completing the project or having the project successful. So having said that, so I'll let Vendor tell us about more into why we needed this transformation.
Thank you, Bharat. Well, innovation, it needs transformation, right? And prior to presenting our actual solution, I would like to show a high-level diagram or architecture from the different components involved in our old solution. As you guys can see here, we have applications running in our data centers. We have some other cloud provider, and then another third cloud provider. This is the old solution that we used to have. And provision, connectivity, configuration, and between all those components is not a trivial task, or it was not a trivial task. In addition, if you need to scale, or it involves some complexity also. Disaster recovery it was not easy to achieve. Again, the past enterprise solution here, we had some operational challenges here. High maintenance costs associated with infrastructure. Multiple instances running similar functionalities. We have also servers designed for peak loads, over provision, right? Licensing model tied to the CPU. Also, server patching was not an easy task, and it was complex and risky. Those insights here shed some light on our old infrastructure landscape. And then we recognized the need for the change. Over here we have two columns. The first one is area for improvement. The other one is proposed change. What happened during this process is we did seek cost reduction, and we achieved that by moving away from mainframe and physical servers. Also, implement new functionalities aligned with the business. We achieved that by adopting ROSA, Kafka, and other services on AWS. Enhance the capability to manage increased loads. We achieved that implementing on demand and auto scale to save some money. Align technology initiatives with the business goals. We achieved that addressing or eliminating some technical debt. Those changes here addressed our past challenges with the old system. With that, I'm going to give to Bharat again.
Thank you. Thanks, Wender. So you guys got a glimpse of our past state, which is not really bad. It served us for 2 decades, and it worked well, but it's always, in the current world, being slow is kind of being down. So we wanted to, we took the opportunity to basically modernize this and improve the things that we were really lacking or we are having troubles with, to make sure we have that pace. So when we do this, when you take the architectural decisions, there's a lot of people involved, the EAs, the solution architects, there are a lot of technical resources are all involved. And we have our own requirements from the security, from the operations, from a lot of different teams. And I'm just going to summarize a few things here so that how we decided to have that solution. So first thing, we have a really good relationship with our partners, the existing ones. And we also have a really good relationship with AWS. So a lot of our applications are already on AWS Cloud. It's a very big footprint that we have on AWS Cloud. So we always wanted to have something, a platform that we want to build to be AWS-based. And then, since this is on-prem, we were already having this development technologies based on IBM MQ and IBM App Connect Enterprise. So we wanted this platform to support even these ones. Now we are going into this new world and new technologies and where containerization is key. So we wanted to make sure that the applications are containerized, and we wanted to push it or deploy or run in a fully managed container solution. IAC, I want to really touch this because at Erkanda, we are really good at automating our infrastructure, especially on AWS. We have automated provisioning using Terraform, so we have a really good practice. So we wanted to make sure that when we provision the clusters, we wanted to make sure that it's through Terraform. So that one was ticked. And since we are improving the cloud, or we're moving to the cloud, we wanted to make sure we also improve the delivery as well. And that's when my part comes in. So we wanted to make sure the GitOps and DevOps are really integrated well, and the solution, the platform should support out of the box. And the one important factor is GitHub Enterprise Messaging Platform. We have Kafka, that is part of it, part of the solution itself. We wanted to make sure when we move to a new solution, it should support a managed Kafka service. And we want to reuse the existing Cloud Pak licenses when we move to the cloud. So those were the architecture decisions, what we needed to have this on as a platform. So let's say these are specific to the ops or the message hub that we are trying to improve. It's only one system. We have 6 different systems that Wender has showed you. There's a small diagram of it. imagine 6 times of it. So we wanted to move one by one, wave by wave, so that we learn from the initial migrations. So these are the key requirements for our ops one. So we wanted always it to be available 99.95%. We can't entertain or have the luxury to be down. So it's really critical system. So it has to be up all the time. And that's when we have this region separation and the DR and real-time synchronization. So that if one region goes down for some reason, which is really rare, but it might happen, we are always prepared for it, and then other region picks it up. For our capacity, we need to manage or support 12.5 million messages per day. Also, sometimes need to process or support 400 messages per second, which is at the peak. Because we have a lot of partners as well, and we are growing, and we wanted that to be seamless, so we don't have to provision infra. We should be scalable infinitely. When we talk about performance, and we talk about the numbers there, but we wanted to make sure that every message that is going through this platform is processed in less than 2 seconds, 99.5% of the time. And security is a big thing, so we wanted to make sure the platform that we're going to take out of the box should support integrations to our security tools as well. We have our SIM tools where all the audit logs, a lot of other logs that are shipped to that, and we have a dedicated team that actually monitors it. Unwanted knocks on your systems, everything are basically logged there, so they are really proactive, and we can basically remediate those risks. The other one is the biggest part is the observability. Observability for us, we have an enterprise monitoring tool. That tool has to integrate, or the platform has to integrate with the Dynatrace or Splunk or the other monitoring systems that we have. Because we have our operations team, which actually monitors these systems 24/7. So they have that single pane of glass where everything is visible, all the systems are visible at one place. So, having said all this, I'm going to give it back to Dustin to let us more about the app platform.
Thank you, Bharath. At this point, we've kind of walked ourselves into a discussion about why would we choose an app platform and how would it help Air Canada. We've seen the requirements, we see what goes into it, but I want to emphasize the word choice because we really want to understand why we would actually choose an app platform in this instance. So why do we need an app platform to begin with, as opposed to what I like to say is just a place to run applications, and it stems from our customers. You've heard Air Canada say several times here that customer experience is key. So our customers really, they have needs and wants. Our businesses must respond to those needs and wants. They're going to leverage the support of IT to respond to those needs and wants. IT is going to produce applications and maybe have in-house developers to produce those. And at the end of the day, our customers are consuming those applications. This is why we say innovation in IT happens at the customer level, because whether we realize it or not, our customers are driving all the changes that we do. Now, unless you're at a Red Hat or an AWS, you're not producing revenue by having IT. IT becomes an overhead cost for your business. So the goal here is to actually reduce overhead so that we don't have that additional cost and additional burden that IT has for us. We can do that by choosing an application platform that has all the capabilities that our applications need, that our customers are driving. If we don't choose an app platform, we decide to build it ourselves, we walk into what I call the app platform problem. And you see pictured up here, this is what a typical containerized application platform looks like. We've already decided enterprise messaging platform needs to be containerized. You see the buzzword Kubernetes there at the heart of that. Well, Kubernetes is not an app platform. It's a container manager. It understands containers. It doesn't understand application needs. It doesn't have things like monitoring, logging, CI/CD, et cetera. So we've already determined we're not revenue producers, so we don't want to spend cycles actually building this ourselves. So it turns into what I like to call, those old choose your own adventure books. And if we take that as an example, if I take the logging column, and I would fill that myself and decide to build this myself, and I would choose Elastic for that logging need, and I would flip to page 31, maybe in a future iteration that doesn't meet my security needs, right? Sorry if anybody is from Elastic, that was just a hypothetical example. So that's the kind of situation we get ourselves into, is we have to manage that, over time, and we're not revenue producers, so we don't want to get ourselves into that. And if we did happen to do this ourselves, and we did it right, we would end up with OpenShift. And you can see OpenShift looks, very similar to what we saw on the last slide, except for it's filled all those question marks we saw on the last slide with mature, best-of-breed CNCF projects, and it supports all those integrations across multiple versions. Additionally, it enables more modern workflows. We looked at GitOps and CI/CD as one of those things that wanted to be improved in EMP. So we have that available to us within OpenShift as well. So it has all the things that applications need really ready right out of the box. Now, it'd be a little disingenuous to say that it has everything out of the box that you need. Taking the example of Dynatrace and Splunk. Those are two good examples. OpenShift can't predict that an enterprise has chosen those for their observability needs. So where it can't predict that, we have a way to integrate with that. And we do that by using Operator Hub. Operator Hub allows us to essentially layer on operators on top of OpenShift. If you're unfamiliar with operators in Kubernetes, they're essentially just like packages are to RHEL. Allows us to configure those and configure those integrations with our enterprise as well. So this is why we call OpenShift a complete app platform. And this is where ROSA comes in. So if we've already told you that OpenShift is a complete app platform, why do we care about ROSA? The answer is pretty simple. Essentially, AWS and Red Hat have partnered together. They understood the value of having an app platform and reducing overhead within IT organizations. And, but they also understood that there were some gaps, right? There are ways to deploy OpenShift into a AWS environment. That's not solved for us if we self-manage that ourselves. How do you do day two things like monitor it, upgrade it, alert on it? So there are some gaps, and AWS essentially used our long-term partnership and our common customer base to produce what's now known as ROSA. So ROSA can be simply explained as having your app platform and having it managed by somebody else. That somebody else is a team of dedicated SREs. We're going to talk about them in just a second here. But essentially, you're getting all the value of OpenShift and having it managed for you. And then across its lifecycle, it's being jointly engineered and maintained by both experts in the public cloud space in AWS and experts in the app platform space in Red Hat. So you can be confident that that's going to continue to mature and meet your needs. If you take a quick comparison, I think we've beat up the DIY app platform pretty good. We know what OpenShift is. I want to highlight EKS here. So there are going to be times when businesses are going to have needs and they need full-on customization and they need to be able to do this themselves. And when those needs arise, EKS is a very good choice to do that. It takes away the pain of managing the Kubernetes control plane. It fills in some of the blanks that we saw on that other slide that some of our applications need, like ECR for images, CloudWatch for platform logging. Generally, what we see is that more mature Kubernetes customers are more apt to go down this path. Now they've got a lot of engineering power behind them. They've got a lot of experience in this field. But where that's not ideal for some customers, that's where ROSA comes in, right? ROSA comes in and it takes the full-on app platform experience and it passes that management layer off to a team of dedicated SREs. That SRE team is responsible for monitoring, alerting, upgrades as you request them. They are monitoring that platform 24/7 and they are bound by a 99.95% SLA. In addition to the SRE team that's taking care of this platform for you, we have other teams that you can leverage. Teams like, I'm part of the Black Belt team. You can leverage us to get your first cluster stood up, right? We have a customer success team. They are responsible for helping you onboard your first workload. And what that really allows you to do is leverage expertise as a free service to you to help get the most out of your investment faster. If we take a look at what ROSA actually looks like, and I just want to pause, this is the current generally available version. We've got a new iteration coming that's going to look a little different than that, but speaking as to what we have today, this is what you get with ROSA. And by deploy, we can do UI deployments, CLI deployments, Terraform for infrastructure as code. There's community projects out there around it. So a lot of different ways you can put it into this architecture here. And what you actually get is you get EC2 instances that represent the control plane, the infrastructure, and the worker nodes. You get an API that ties back to the OpenShift load balancer. A load balancer that ties to the API server for OpenShift. A load balancer that ties to the ingress for routing to your applications. You get a private link, which SRE is going to use to access your cluster to manage it. You get DNS entries tied back to those, so you get a whole slew of things that are part of this architecture. But I do want to highlight 3 things that Eric Canada pointed out that a lot of our customers also need as well. First of all, availability. So with the simple deployment flag, I can basically put this into a highly available scenario, spread across multiple availability zones so that I can tolerate an AWS data center failure. That becomes part of the managed offering now. Security. I can deploy into a set of private subnets so that I don't expose my applications to the public internet, and I can work in a sort of disconnected scenario. Scalability. On the bottom there, I see a set of EC2 instances. Those are part of what we call a machine pool in ROSA. In that machine pool, we have cluster autoscaler as part of the managed experience. And what cluster autoscaler is responsible for is it detects when that machine pool is at its capacity, and it can scale that capacity on demand. So that becomes all part of the managed experience and things that you would have had to think about before, but you don't have to think about anymore. In addition, ROSA is treated as a native AWS service, so we can integrate with other things that AWS has as well. Now, we're all here at reInvent, so we all want to get the most out of our AWS investment. So ROSA can do things like integrate with CloudWatch for logging, for your application logging, by way of log forwarding. It also has the Amazon controller for Kubernetes, which allows you to provision and manage some of the AWS objects, just like you would any other OpenShift object as well. How does it work? If we take a look at what a self-managed model actually looks like, if I'm self-managing this on AWS, which I can do, I'm responsible for the EC2 instances, the load balancers, the DNS entries, all the things, all the infrastructure that goes into that platform. If I have a problem, I can open a support ticket with Red Hat. They're going to take care of my needs. My subscription cost comes from Red Hat. If we flip that model a little bit, SRE now becomes responsible for that infrastructure for me, so I don't have to actually worry about that. And I do want to draw a quick line in the sand here. You are responsible for your applications. That part doesn't change because SRE doesn't understand your applications as well as you do. So you're still responsible for monitoring your applications, logging, all the things that go into the applications on top of the platform. The platform is what SRE is ultimately responsible for. From a support perspective, you can open a support ticket with either ARM, so either AWS or Red Hat, whatever you're comfortable with. That becomes routed appropriately, so it becomes kind of a choose your own path for support there. Billing gets greatly simplified because we are treated just like a native cloud service in that I get one bill, it comes from AWS. I do not get 2 bills, one for my cloud consumption and one for my Red Hat subscription. So that becomes another benefit of actually having that as a service. In addition, there are several personas within your organization that actually benefit from this. Developers can be confident that they can build, deploy, and run their applications because they are using OpenShift, which is a complete application platform. Administrators can now focus on developers and the developer applications. They can focus on innovation and modernizing things like GitOps and CI/CD, which we've looked at as well, which ultimately are going to benefit our customers, which is where our focus is really at. Business leaders, I can leverage my AWS commitment to burn down my ROSA, using ROSA. I have a 99.95% financially backed SLA. And I get a 24/7 management from an expert SRE team that are used to managing these clusters at scale. One of the unrealized benefits of that is anybody who's had to hire those folks with that talent, it's hard to hire them, it's hard to retain them, it's hard to train them. So that becomes something that you no longer have to worry about with this service. And if I leave you with nothing else today, ROSA is a managed application platform. What it is really intended to do is to free up your time so that you can focus on what matters, and that is the applications that serve your customers. We do that by reducing the operational overhead, by passing that burden on to a dedicated SRE team. Another thing that it does is it allows you to accelerate your modernization efforts when things like enterprise messaging platform come up. With that, I'll go ahead and pass it back to Bharath to talk about your infrastructure.
Thank you, Dustin. Okay. Yeah, there was a platform. It has a lot of features, and we actually used and abused all of them, the operators and everything. It was really easy to integrate with all of the systems that we have. So where we ended up, what you see on the screens is a really, really simplified and a really high-level diagram of the solution or the platform. You can see that we built this platform not just with ROSA, with a little bit more services on AWS as well. So we use managed Kafka service. We moved from the IBM event stream to Amazon managed Kafka service. We have some of our images hosted on our Amazon ECR. And also, we integrated with our enterprise tooling. So when you build a platform, as I said, it needs to integrate and adapt to our own existing tooling. So we have a lot of our applications and the source code repository on our enterprise source code repository. We have integrated with our identity provider. It was easy, or you have to say it was better and worked really well integrating with our network as well, so how the partners interact with our system. So we have them on the monitoring and the observability side. We were able to do it easily with the operators concept, and we did integrate with our Dynatrace and Splunk cloud. And for message enrichment, we can interact with the other systems in AC. So let's look at what we actually put on ROSA and actually what we deployed on ROSA. So we have all the Matip client and server applications on it. So this is used to basically interact with our partners who use this protocol. So Matip, if a lot of people know, it's a 60-year-old protocol. It's still used, and it's really specific to airline, and we still need to support it. So some of our partners still use it, so we have to support it. Some partners use MQ. So we have our MQ client and server deployed, and our MQ applications on ROSA. Our Kafka ones as well. And we have the IBM App Connect applications deployed on ROSA. So you can imagine it is so flexible that we can deploy any type of applications and serve from ROSA. Last but not the least is the Kafka Mirror Maker, which actually is a critical one because that's how we actually synchronize between the primary and the DR region. So now that we took how we improve the infrastructure side and how we run these applications, let's look at the DevOps side of things as well as the GitOps. We improved significantly. If I have to say if there's another word more than significant, I don't know, but we did a lot of big strides in improving these things. So now it's more streamlined. ROSA comes out of box, or the OpenShift generally comes out of box with some CI/CD capabilities. It's part of the platform services. We use Tekton pipelines and Argo CD. So the Tekton for building the applications and the Argo CD to deploy to the environments. So which is specific to the containerized environments. So we wanted to leverage that, and we built a practice around it, and it's so good that we're moving things much more faster when we are trying to move the other other message apps as well. So in summary, what we ended up or what we improved, now we have one single centralized platform, not 6 or 7 or 8. So we were scaling based on the need before, but now we have only one single platform, and everyone can be on that platform if you need anything related to the messaging. We changed from paying for the CPU provision or the resource provision to how much we use right now. So we are only billed for the consumption because before, when we were on-prem, we used to size these servers or these environments based off for the peaks, but you will always not have the peaks all the time, so we were wasting the resources. Now we are more flexible, so we only, and it's going to cost us less because it's consumption-based. We don't have any manual deployments anymore. No waiting for resources. Someone has to go in, move the artifacts, or make the changes, restart the servers. No, we don't do that anymore. So it's more automated right now. And we increased from hours, or days, hours, to basically minutes and seconds. So it's much more faster. And now these deployments are developer-led rather than we need someone dedicated, an ops person, to basically run them. And again, we moved into containerized builds, so it's good. Our applications are built much more faster, more lighter, because we're containerizing it. At the end, doing changes is much more easier because it's just a YML file that you make a lot of small changes there, and it's going to be reflected. You try it on your lower environments super fast. You see the difference. Oh, it's good. You can go to the production environments much more faster. Having said that, I'll hand it over to Vendor.
Hello.
Yeah, I think you're good.
So I am to be realistic and transparent here. When we face challenges during this process, right? Journeys like this are not easy. If someone offers you an easy solution, they're likely presenting you a non-realistic approach, right? Support model in this situation, where we had ROSA from one side and Amazon on another side, you can think like two products, but they are all together in a portal, AWS portal. When you open a ticket, they're going to respond. You have one entry to open your tickets. But I want to share our experience with the support model that demonstrates a great effectiveness throughout all those implementation. We had quick resolution problems. We had a collaborative effort to bring new solution, to adapt to our needs, to fix some other needs, integration, because the complexity behind those systems, it's big. What worked well? In an overall experience, we are now handling more message traffic in the system. Also, we have high availability with ROSA. We reduced our operation expenses by doing scale out and scale in as we need. Faster deployment, real-time updates, and integration with CI/CD, like Bharat mentioned. That's a win-win for us. We planned during this process here, right? Without compromising time, cost, and the scope of the project. At the end, ROSA and other AWS services, they were chosen. We faced some challenges, for sure, but the collaboration with AWS and ROSA team, especially the black belt team, was very good. I call them the ninja, because you open a support ticket, they're gonna reply from Australia, and then from Europe, from US, from South America, from Canada. They are everywhere. Looks like it's not black belt, they are ninja, right? Monitoring, observability, AWS services, ROSA, Dynatrace, Splunk allow us to prevent one event to become an incident. That helped us a lot. While facing some challenge throughout all those implementation, I believe it was a smooth transition from on-premises to new system on AWS. Because when we need to scale fast. When we need to go to a DR, we need to go quickly. We are using our ability to deploy infrastructure as a code using Terraform, very important for us. And Mirror Maker also between two regions. That's a win-win for us. What's next? We adopted ROSA as our standard container solution. What we are doing right now, we are containerizing applications that are running on-premise and shifting that to AWS to run on ROSA. Also, we are refactoring when need, when possible, and shifting that to ROSA. On top of that, whatever application, other application that was running in other different cloud providers, I show in our past scenario architecture, we are migrating those applications also to ROSA. Again, ROSA, we adopted ROSA as our standard container solution. I used to work with, I'm still working with ECS, EKS, Kubernetes, but ROSA gave us a very good experience. And with that, we are open for Q&A.